Namaskar, this is Professor Eslal from Jyoti Vidyapeeth Women's University, Jaipur, and I'm going to discuss some aspect related to optimization technique. Students, you know that the role of variables in any computation is very important, and with the help of a function, with the help of single order variable, or with the help of second order variable, it is possible for us to forecast the aspect of optimization. So today in this lecture I am going to discuss about direct search method, and let me allow to share the screen to discuss about some facts. I hope this is visible to you. This is direct search methods in optimization technique, and sometimes it is said that these direct search methods help you a lot in the dynamic questions of several variables. Means if you are discussing about function and if you are discussing about several variables in context to optimization technique, if you are engineering student or if you are engineer, you are working in industry, then you may face day-to-day problem that how to optimize this problem. So for that, we are here to discuss in brief about some techniques that are called direct search methods in optimization technique. So you see, please examine methods or algorithm that iteratively produce, means repeatedly produce estimates of X star that set up design variables that causes effects to take on its minimum value. This method work equally well for maximization by letting the objective by minus fx. And you see, the methods that have been devised for the solution of this problem can be classified into three broad categories based on the types of information that must be supplied by the user. And what are these three broad categories? The first one is direct search method, which use only function value. Means in direct search methods, we use directly the function value. In gradient methods, that is in serial number 2, these require estimates of the first derivative of fx, and second order method, which requires estimates of first and second derivatives. So you see, I hope you have seen these three categorization as direct search methods, gradient methods, and second order methods. So no one method or class of methods can be expected to uniformly solve all problems. It means if you are interested or if you are curious to know that is it possible to solve all the problems by the help of a particular method? No, it is not possible at all, because no one method or class methods can be expected to uniformly solve all problems with equal efficiency. For example, in some applications, available computer storage is limited, and in others, functions evaluations are very time consuming. And the third one is in still others, great accuracy in the final solution is desired. So clearly it behooves the engineers to tailor the method to the characteristics of problem at hand. Methods for unconstrained minimization problem are relatively well developed compared to the other areas of non-linear programming. And as I shared with you in the beginning that what is direct search methods. So you see, in direct search methods or the direct search method required only values of objective to proceed. Means in you have seen in linear programming problem that there is a objective function, and with the help of that objective function we come on the point or conclusion that whether we are going to maximize the value or we are going to minimize the value, or what will be the maximum or minimum value of the given function. Means that is decided with the help of optimization objective function also. But in so many cases there is confusion and we fail to create objective function. So you see the next line, direct search methods are especially useful when there is noise or uncertainty in the objective function evaluation. And the next point that we should remember is multivariable methods that imply only function values to guide the search for optimum can be classified broadly into heuristic techniques. Means just by your own common sense and the theoretical based technique. The heuristic techniques, as the name implies, are search methods constructed from geometric intuitions for which no performance guarantees other than empirical result can be stated. The theoretical based techniques, on the other hand, do have a mathematical foundation that allows performance guarantees such as convergence to be established at least under restricted conditions. You see three direct search techniques in direct search methods. There are, three direct search techniques. First one is simple search. The second one is Hooke-Jeeves pattern search method. And third one is Powell's conjugate direction method. First two of these are heuristic techniques and the exhibition fundamentally different strategy. The simple search method implies a regular pattern of point in the design space sequentially, whereas the Hooke-Jeeves pattern search method implies a fixed set of direction in recursive manner. Powell's method is theoretically based method that was devised assuming a quadratic objective and for such functions will converge in a finite number of iteration. The common characteristic, you see here, the common characteristic of the three methods is that computationally they are relatively uncomplicated, hence easy to implement and quick to debug. I hope you have a little bit understand that what is direct search methods and how they are categorized, what is the significance, and how we proceed on a convergence decision, on a solution, convergent point in case of solving industry problem. So thank you very much for listening and enjoying. You please wait for my next lecture on optimization technique. Thank you very much. Thanks again and namaskar.